So section 4.4 is just more factoring, which we've done in chapter 3 a bunch. We had a review this week on factoring. It was actually factoring with solving. That's what we did this week. This today is just factoring. We will, of course, do solving as well. Just to review the rules for factoring, what do we always factor first? What do we always factor first? Always. Yell it out. The GCF, thank you. The GCF, the greatest common factor. We must always factor that first. After we do the greatest common factor, then we look to see how many terms. And it's 2 terms, 3 terms, or 4 terms. If we have 3 terms, the one in the middle, if we have 3 terms, this is where we're going to factor by guess and check. This is where we say what multiplies together to give us C. And then like what multiplies together to give us AX squared. You know, we're going to put those things in there. We've got some signs in there, and then we've got to guess and check it. We're basically guessing what goes in there, and we're checking to make sure that it multiplies back together. Okay, we've done that a bunch. We'll do some more of that today. If it has 4 terms, I don't know what I'm doing. I'm making things up here with letters. If it has 4 terms, then we have to factor by grouping, which we'll review today. I teach pre-calculus, and guess what they're doing? Anyone want to guess? Well, they're solving trigonometric equations, but they're using factoring to do it. So this factoring thing is not going to go away. It's something that's really, really important. It's one of the top maybe 2 things that you should learn when you leave Algebra 2. So very important to be doing these assignments on factoring. The last category would be factoring 2 terms. And prior to today, we only knew one method. For factoring 2 terms, we could do a difference of squares. If it was a squared minus b squared, we would factor it to be a plus b, a minus b. That was the only 2-term factoring that we knew. Today, we're going to learn an alternate 2-term factoring. So this is going to be new. So we could have a sum. Hey, come on. There we go. Or difference of cubes. And there is a formula for that. It's on the next page. I'm going to write one of them here real fast. It is basically something you memorize. So if I have, and of course I'll go over it when we get there, but if I have a cubed plus b cubed, I'm going to factor it to be in the form of a plus b, a squared minus ab plus b squared. So that's the formula. It's on the next page. We'll get there when we get there. But that's going to be new today. So if you're trying to write down that formula, it's on the next page. It's also in this video I'm recording. So Factor each polynomial completely, and the direction said something about a greatest common factor, but the direction shouldn't need to say it. We should always just look for greatest common factor. You notice there is an x that is common in all three of these terms. So I'm going to factor out that x. After I take out that x, I have x squared minus 4x minus 5. This says to factor completely. So after I take out the x, I look and see what's left. I have a trinomial. I started with a trinomial. I still have a trinomial, 3 terms. So to factor 3 terms, we do the guess and check. So the x out front stays. But now I'm going to factor the trinomial further. So we look, and it starts with an x squared, so that's going to be an x and an x. It ends with a 5 or minus 5, so we know we're going to have 1, 5 and 1, 1. But because it ends with a negative, what does that tell me about my signs? Same or not same? Not same. So I just have to figure out which one should be negative. So in order to get that minus 4 in the middle, I want the negative to be with the 5. If I'm not sure if I did it right, I should check. I should multiply back together. Minus 5x plus 1x. Yes, that does equal minus 4x. So my answer is x parenthesis x plus 1 parenthesis x minus 5. If you have the x minus 5 first and then the x plus 1, it's the same answer. But we do always put the GCF in front. Question B, the GCF, 3 and a y to the third. So we take that out. And I'm left with y squared minus 16. That is 2 terms. So we can use our chart above. If it's 2 terms, do we have subtraction, a difference of perfect squares? Yes. So then we're going to use that difference of squares formula that says 2 parentheses, 1 is plus, 1 is minus, and then we square root. So y and y, 4 and 4. The GCF goes in front. The order in which you put your plus 4 and your minus 4, that doesn't matter. You're trying to factor until you get a degree of 1 in each factor. So since this is y to the first, I know I can't factor that further because this one was y to the second. It tells me I might be able to factor that further. It doesn't mean I always can. It says I might be able to. Okay, the next one we've got common denominator of, greatest common factor of 5, and then z to the second. So z to the second plus 6z plus 9. That gives me 5z squared times z plus 3 and z plus 3, which this one we have to write it squared if they're exactly the same. These are all looking familiar, yes? Yes. Okay. The next section is like just factoring completely. I think it's student practices. Okay, it's student practice, so I'm going to go to the next one. All right, now this is factoring cubes. Factoring 2 cubes. There are 2 formulas, but I tend to only memorize one of them and use it for both adding and subtracting, and I'll show you why in a moment. So what the formula is, if we've got 2 cubes and we are adding them, we take whatever it was to the third power, whatever was to the third power, whatever's to the third power here goes here. Whatever was to the third power in the second spot goes in the second spot. So when it says a to the third, this is a, b to the third, that's b. The second parenthesis, whatever is in this spot here, I have to square it to put it in that spot. Whatever's in the second spot, I square it and put it in the last spot. The middle is you multiply the two together and subtract them. So once I get the first parenthesis, I get my second parenthesis from the first parenthesis. So I'm going to show you how that works with this example they have right over here. They have 64x to the third plus 1, and they've changed it. They've changed it to 4x to the third plus 1 to the third, because 4 to the third is 64, and obviously x to the third is x to the third. 1 times 1 times 1 is 1. So they've changed it so everything says to the third power. Now what I do is I put each of those numbers in the first spot. So my 4 and my x become my first term, 4x. And then just one of these ones is the second term. So we get our first parenthesis, 4x plus 1. To get the second parenthesis, I take my first number and I square it. I do 4x times 4x. And that's how they got 16x to the second. I take the last number and I square it. I do 1 times 1. And that's how they got 1. In the middle, we do subtract 4x times 1. So we multiply the two numbers together. And yes, it's always subtract for that one. So now the difference of cubes works almost exactly the same. So I'm going to do the formula for the difference of cubes. I'm going to go off of the sum formula. So the difference of cubes would be a cubed minus b cubed. Now, the difference of cubes, you just change it into sum. Here we go. I'm going to change it into the sum by doing this plus negative. See that? Now, when I do my formula, I'm going to have a plus, instead of a b here, I'm going to have a negative b. Okay, because we're just still doing the a and the b, but the b is negative this time. That's my first parenthesis. My second parenthesis, I have to take my first number, which is a, and I have to multiply it by itself. What's a times a? A times a squared, right? Okay, and then the last one, the very last number in the parenthesis is this one times by itself. So what's negative b times negative b? Positive b squared. The middle term is always minus, and then we multiply the two terms together. So we multiply a times negative b. What is a times negative b? Anybody know? Amar? It is negative ab. Okay. If this looks kind of confusing, we can clean up the formula a little bit. That says we do a minus b, a squared plus ab plus b squared. But I just showed you that the sum and the difference formula are exactly the same, but because the difference formula has some negatives in it, it changes a couple of the signs. Each of these formulas has one negative sign in it. Each of the formulas has one negative sign. each of the formulas has one negative sign, only one. But other than that, they're exactly the same. So looking at the example that they gave us right over here for cubes, so a difference of cubes, we're looking at 27x cubed and 8 cubed. And we're saying what times itself is 27. What times what times what is 27? What to the third is 27? 3. Then what times what times what is x to the third? X times x times x. Minus what times what times what is 8? 2 to the third. So that's how they're getting this parenthesis right here is we're changing 27x cubed and 8. We're changing it into thirds, or cubes, I should say. So the 3x is the first number and the 2 is the second number. The second part of the parenthesis is always the same. We take 3x times 3x. The last number, we take -2 times -2. And then the middle number, we subtract 3x times -2, which becomes a plus 6x. So let's try one of these that doesn't have it done. And also, I don't know if you see this list of perfect cubes. It might be helpful if you have a list, if you don't know these. Let's say if I did 1 to the third, that's 1. If I do 2 to the third, 8. If I do 3 to the third, 27. 4 to the third is 64. Anybody know 5 to the third? 125. Good. This that I'm writing down is going to be very, very useful in chapter 5 as well. 6 to the third. Woo, yeah. I don't think we see 7 to the third very much, but it's 343. 8 to the third is 512. 9 to the third is 729. 29. And 10 to the third is 1,000. So if you have those handy, then you won't have to goof around on your calculator as much. Okay, so we're going to factor x cubed minus 125. First thing you want to do is write it as cubes. So x cubed is already written that way. 125 is what to the third power? Just put it in the list. 125 is what? 5 to the third power. To factor this, we just take the x minus 5 and we write it as the first parenthesis. What was to the third power? The x and the 5. Oh gosh. You can also think about it being this way, plus -5. Think that way. Okay, then the second parenthesis, we've got x squared. Our last number is going to be 25. And then our middle number is always minus the 2 multiplied together. So I'll have x times -5 in the middle, which I can simplify. That was kind of messy, sorry. I can simplify to be plus 5x. I do another one. What is our first step? What's our first step? Do the cubes. The 16 a cube. Is 16 a cube? We just made a list of cubes. Was 16 on that list? Okay. Why? Well, also here, is 5 a cube? Does that mean we can't do it? What am I missing? Nobody's going to say it before I... What do I need to do first, always? Anybody? Was there a greatest common factor to factor? Yes, there is. What is it? Oh, you guys are killing me. Seriously. Macy, what is it? What number divides into 16 and 54? Can't hear you. 8 doesn't go to 54. That's 9. How about think smaller? 54 isn't divisible by 4. Think smaller. Did she say an answer? What do you notice about 16 and 54? They are both what kind of numbers? Can't hear you, hon. Yeah, so it's divisible by 2 for sure. If I divide out 2, I'm going to have an 8 there, which is a perfect cube. If I divide 54 by 2, I'm going to have a 27. What about the S's? Do we have any common S's there? Yeah, we've got 2 of them. So I'm going to take out 2s squared, and I have left over 8s to the third plus 27. Now, since these are perfect cubes, let's think about writing them as cubes. So this would be 2 to the third, s to the third, plus 3 to the third. When it looks like that, I can use my cubes formula. I bring down the GCF. That just stays out there the whole time. The next parenthesis is going to be 2s plus 3. I just got rid of those thirds. My second parenthesis, I take the first number, 2s, and I square both numbers, or both the s and the 2. So 4s squared. I do the last one. 3 times 3 is 9. The middle is always minus these 2 multiplied together. So 6s. So it's really just a formula that you're plugging stuff into. One thing that I did not do, and I was waiting for somebody to ask, but since you guys aren't talking to me at all, one thing I didn't do, but did you see I never went and did anything with this trinomial? Does this trinomial factor further? You notice how I never went to check that? The reason why I didn't go to check that, and in their formula, they do not have that factored any further, is because it will never factor further when you use the cubic formula. It will never factor further. So if I know that I'm using the cubic formula, I know I don't have to check this. Otherwise, you should probably just check it if you don't remember that. But it will never factor further. The binomial might factor further. Could factor further. But the trinomial will never factor further. Okay. Let me do a factor by grouping example before the end of our class. Factor by grouping, just to remind you, we have to have a plus sign in the middle. So the first thing I notice is that we have a minus sign in the middle. So I'm going to make it plus negative 4z. And then I will group them. So I have to have that plus sign in the middle. Then we look for factoring the individual groups. So this one has a z squared I can pull out. And the other one, I'm going to have to take out a negative 4. From here, for both sides, this becomes a binomial now. I can take out the z plus 5 from both of these, which goes in front. And then what's left over is z squared minus 4. So it was factor by grouping, but I'm not done. I know I kind of hurried through that, but that we've learned before. So factor by grouping. The reason why I'm not done, though, is now in this section, they're going to give us ones that, oh no, I still have a squared in it. Does that factor further is the question that I need to ask myself. So z plus 5 does not factor further because it's to the first power, the first degree. But z squared minus 4 is a binomial. It is a difference of squares. Difference of squares. So we will do z plus 2 and z minus 2. And now those z's are to the first power, so I can be done factoring. So I think that this is the biggest thing about this chapter is we now have cubic, and we now have ones that will keep going on occasion. I want to find one more that's on the last page, and I'm going to put it on the video, even though the bell rang. It's going to be A, question A. So this, when I look at it, and I notice there's a fourth here that is not cubic. It is, however, a difference of squares. So the way I would factor this one first would be 4x squared and 4x squared, plus or minus, and then this would be 9 and 9. And then we see if we can factor it further. 4x squared is not a difference of squares because it is a sum. So this one is done, even though it has a squared in it. But 4x squared minus 9 is a difference of squares. So this one can go further. And once you hit first power, you know you can't go any further. The assignment is a factoring worksheet. You do not solve for 0. You're just doing the factoring part. And I'm going to have you guys type it in for this time. Okay, so you want to make sure that you're asking questions. You'll have multiple tries. You could try number 7, 18 times if you want. Probably not 18 times, but you can keep trying it over and over again. You don't have to fill in the entire form every single time. Just fill in the whole form the last time. Okay? All right, good day.